Alright, pop stars, let's get popping. So this is the second homework that was given out actually today, Wednesday, Halloween day, which I know means you guys are all at home right now working on it. But on the off chance that you're looking at this on Thursday or Friday, no big deal. This is all going to help you with your quiz that's going to be due Sunday anyway. So consider this diagram below and the following congruency statement. Label the diagram appropriately and list all pairs of corresponding congruent parts. So we can actually do the second part of this without labeling it, but labeling it makes it so much easier. So let us do that. So we are asked to label this, and we got to do it a little carefully because hopefully you guys have noticed that there is a shared vertex right here in the middle. So we're looking for a shared point. Oh, look at that, shared A. So automatically I know that's A. I'm going to say this first triangle is the upper triangle. So ABC, I don't think it matters. We're just going to put a B here and a C here. The bottom is going to matter a whole lot more because we know that these have to be corresponding and congruent in pieces. So A is going to be shared in both of them. Looks like this goes up to B to like the rightish looking angle and over to C. So I'm going to do the same thing down here. I'll go from A down to D and then over to F. And if you're wondering how I did that, well, look at the order. A, B, C, A, D, F. So that's A, the shared point, to the rightish looking angle over to C. So A, the shared point, to the rightish looking angle D, then over to F. Now we actually have to list all pairs of corresponding congruent parts. Well, we could do that from here, but it's just easy to do it up here, or maybe use a combination. So I'm gonna handle the sides first. So if I'm looking at, say, like the first two letters in this sequence and the first two letters here, the order matters so much it actually tells me the corresponding pairs of sides and angles. So let's handle this first. So we have the AB, and that's going to be congruent to the AD. Inline segments, of course. Now, if I switch my focus, let me get a little eraser going here. If I switch my focus then and looking at like the next two pieces, we have a BC and we have a DF. Again, order matters, so we're looking at BC congruent to DF. Last bit, well, this is kind of going around the horn. We're going to go C back to A, and like we're going to go F back to A. So CA congruent to FA. Now we could probably go back through our diagram, and we should go back through our diagram and make sure this makes sense. Here I have AB and AD taken from our list, BC and DF again taken from our list, CA and FA. So CA 1 2 3, FA 1 2 3. So again, the picture should make sense, the list should make sense. Now let's talk about angles. Again, you see me do this several times now, and I try to push this idea in class as much as I can. But instead of using like the 3-letter naming convention for angles, I'm just going to use something else. I'm just going to number them. So 1 2 3 4 5 6. So we marked this diagram. We could take this from our congruency statement, but I think a diagram actually will reveal the story a little faster. If I'm looking at angle 1, I'm looking at the legs. One's marked with 2 tick marks, the other one with 3, which means that's what I'm looking for over here. The one between 2 tick marks and 3 tick marks. Hey, look at that. It's number 6. So 1 is congruent to 6 will be part of my congruency list. So angle 1 congruent to angle 6. Looking over here at angle 3, that's trapped between the 1 and the 3. 1 tick mark, 3 tick marks. So 1 tick mark, 3 tick marks, that's going to be angle 4. Now, it'd be really easy to sit here and say, well, those are going to be vertical. But hey, wait a second, those aren't vertical. If those are vertical, it'd be just 2 lines forming 2 angles. I have 1, 2, 3, 4 lines forming 4 angles. Those are not vertical. But I do have angle 3 congruent to angle 4, leaving, of course, angle 2 to be congruent to angle 5. Okay. So what's the moral of the story? Well, the order of the congruency statement definitely matters. The picture may be deceiving, so use a combination excuse me, of your congruency statement and a marked diagram to make your congruency list. Okay, so is it true that ABF is congruent to DEC? List all pairs of corresponding congruent parts and justify which pair is congruent. So what we're looking for here is just if you're not told the important all the information, like if it's straight up just not given, do you have enough there to kind of generate the rest? Well, let's go through it piece by piece, and let's see this even enough, because there's no point making a list if it's not all there for us. So I definitely have that this angle is congruent to this angle, so I have one set of angles. But do I have any more? And that's really the important question. I'm looking at this angle at C and the angle at F, and I don't really see a way to do that. Maybe if my lines were parallel and this could be a transversal, I'm in business, but really just knowing that they're congruent doesn't tell me anything about parallelism. But I do have a parallel marking here, and I do have a parallel marking here. That's interesting. If I accept this to be a a transversal, man, I'm all over the place. So if I accept SC to be a transversal, and AB is parallel to ED, I think I'm in business here in terms of an angle. And the reason being because, well, wouldn't this angle at B and this angle at E be alternate interior angles? The angles are, excuse me, the lines are parallel. This is a transversal, so these two angles should be congruent. Let me clean this up a little bit. Okay. Well, if I have two triangles in which I have two sets of angles that are congruent, then the third set should be 2. We talked about it actually this morning or today on the warm-up, depending on when you had class. But we're talking straight up third angle theorem. So if I know these angles are congruent, the purple and the red are congruent, so it should be the blue angles. And if you're wondering why I'm marking them all with a single arc, it's not because these triangles are congruent, but I'm using different colors in the same way you'd use like arcings of multiple arcs. So I definitely have 3 angles that are the same as 3 angles. Let's talk about sides. Well, I have CD with 2 tick marks, AF with 2 tick marks. I have AB, I have ED. So really the only question is CE congruent to BF? Well, if you're paying close attention here, I know that FE is congruent to BC. Well, I have this middle segment that is shared. Well, if I do some addition, if I add FE to BE and CB to BE, that should be enough to conclude congruency. If these pieces are the same and they share the middle, adding same parts to same parts should result in same measurement, therefore congruency. So the answer ultimately is yes. If we're going to make a congruency list, or I should actually maybe frame that as say, let's make a congruency list. Let's do that one piece at a time. So the first set of angles marked in purple, I'll have the angle BAF congruent to the angle CDE. And as for reason why, that was given. I mean, that was marked in the diagram with the arcs. Don't need to work hard on that one. That's given to us. Let's look at our second set of angles, the red ones. This was based on parallel lines and the transversal, so I have angle ABE congruent to the angle CED. And that's going to be because of the alternate interior angles theorem. Not the converse, because we're starting with parallel lines, and so this is going to be just a straight up theorem. Let's go to blue, the blue angles. So the third set of angles, angle ECD, congruent to angle AFC. This was going to be third angle theorem. This is one we talked about just today. If in 2 triangles I have 2 sets of angles that are already congruent, in this case purple and red, then the third sets of angles should too be congruent. Let's deal with sides. So the first 2 sides are fairly boring. I mean, those were just given to us. So CD is congruent to AF. And that's because it's given. The second side equally as boring. AB should be congruent to ED, and that was given. The third side, S3, we have FB congruent to CE. Now this is not a proof, and again I want to kind of overemphasize that point. If this was a proof, we'd actually have to show this addition happening. We'd have to show using segment addition postulate that the measurement FE plus the measurement EB is equal to the measurement FB, and likewise for the CE side. And then we have to kind of show algebraically a progression that determined using a calculation that FB is the same as CE. This isn't a proof, so I'm not going to go through all those steps. But what I can do is offer the main body of this kind of argument would be the segment addition postulate, the SAP. Again, not a proof. I never said I was writing a proof on this one. That's something that's kind of left to you guys. We're starting the study today. We're going to continue in the next couple days. The segment addition postulate is definitely the core of it. All right, so this we're moving to a little bit of algebra right now. You're told that these are congruent, these 2 figures, and you have to find the values of x, y, just x and y. So something to kind of keep note as I'm blowing this up here. You have to look at the congruency statement to understand the orientation. So that's really the first step. If you can do that, then you're pretty much in business. So looking right here at the angle at Q, what's that going to be corresponding to in this figure? Well, I could look at the diagram, but that could be very misleading. But instead, I'm probably a little bit better off looking at the congruency statement. Q is going to be the third vertice listed, so it's got to be corresponding to the third vertice listed in the first diagram, in other words, F. So if I'm looking at the 6y minus x, it's got to be equal to 68. Now that doesn't necessarily help me right now. I can write it 6y plus x is equal to 68, and the reason this doesn't help me is I have two variables, so I have to probably go somewhere else first. But I do have this statement, which I'll kind of annotate in red. I have this QR. I just have to figure out what over here corresponds to, then I can set up a second equation. QR is listed last, so if I look in the first diagram, listed last is FG. So FG is going to be corresponding to this statement. So my second equation, which will be immediately solvable, will be 2x minus 4 is equal to 12. Algebraically, now you just have to kind of work this out. Add 4 to both sides, and we're left with 2x is equal to 16. And of course, then x is going to be equal to 8. Now that I have the x value, it just becomes, again, an algebra problem where I am, where I'm taking this value of x that I found, substituting into the purple equation, and then kind of going to town algebraically. So in substitution, I'll have 6y plus, in this case, 8. Again, 8 came from my previous solve, is equal to 68. Now algebraically subtract 8 from both sides, we'll end up with 6y is equal to 60. Divide by 6, y is equal to 10. Okay. So again, the value of kind of how the order of the name pops up again, if you have the right order in your name, is very easy to decode a problem like this. And this is definitely a problem that I would look to studying pretty carefully, looking forward to the test that will be released tomorrow. Another kind of algebraically based problem. Kind of love these, especially because you have to know a lot about congruency to solve them. It really tests to know if you really are paying attention to order in these marks. Now, we don't know anything about these triangles. In fact, we can't even claim that they're going to be congruent. But what we can do is try to determine if we have enough information here to solve for x and y. In other words, we need equations. I don't know really anything about this triangle. I'm going to completely ignore it for now because everything is a variable. But I am going to try to pay careful attention to this one on the right. I'm looking at this. If this is 90 and that's given to be 40 using triangle sum, this has got to be 50. And that's some really good news, because if I'm looking and trying to match these pieces up, we're good to go. On the right hand, the left hand side, the first thing I have to notice is that this will be a 90-degree angle, kind of indicating that these two very well might be congruent. Don't really know that, don't really care, but just something to kind of keep in mind. I have one arc here and one arc here. It looks like we do have a matching set of information. This 12x plus 4y should be the same as 40. Again, one arc, those are congruencies. So 12x plus 4y is equal to 40. Now, the last piece that we have to kind of incorporate is the fact that we have this last angle at 50, and we have this guy over here, the last angle in the triangle on the left. Those should be congruent as well. It's certainly not 90, and it's not 40 is taken care of, so this one has to be its matching pair. 17x minus y is equal to 50. Now we're kind of left in a pickle, an algebraic pickle, and you have to know how to solve systems to solve this problem, but hey, that's why I took algebra before this class. Let's go ahead and solve this guy. The first thing I'm going to do is actually multiply. Well, let me take that back. I have to determine what kind of methodology I want to use to solve this, and I have some choices. For me, the best choice is probably going to be substitution, which means I actually have to prep this green equation to make that happen. So I'm going to rewrite this green equation and solve for y. I'm going to accomplish that by subtracting both sides by 17x, excuse me, and then multiplying the entire thing by -1. So I should end up with a 50 minus 17x, but indeed, when I multiplied everything by a -1 to get rid of this negative and make it a positive y, I'll end up with a -50 plus 17x. That gives me something. Substitutable. If y in the expression -50 plus 17x are actually the same, hence the equal sign, that means I should probably be able to write this purple equation with the -50 plus 17x in its place. So rewriting here, I'll end up with a 12x plus 4, then in quantity, -50 plus 17x, and that's going to be equal to 40. Now it's time to put your solving hat on, because that's all we're doing from this point forward. 12x, that's going to be a -200. Let's see, 17 by 4. 4, 5, 6. That'll be a 68. And if you're wondering how I'm doing that, I am just distributing. 4 times a negative 50 is a negative 200. 4 times a 17 looks like it's going to be a 68. 68x, excuse me, and that's going to be 40. Again, let's keep solving. I'm going to add 200 to this side, and I'm going to combine my x's. 68x's plus 12, that'd be 60, 70, 80 x's. Should be equal to 240. Last step, divide both sides by 80. It'll end up x being 30. Since x is 30, now all I have to do is kind of pick the equation up here I want to use to solve for y. It is a system, meaning that they're going to be simultaneously being solved. I'm going to choose this one, which I conveniently already solved for y. It's going to make my life a whole lot easier on this solve. Okay. So let's rewrite it with the substituted part for x. So x is 30. So I just need to figure out what 17 times 30 is. So let's see, 17 by 30. That'd be 21, 3, 4, 5, so that's 510. So y is equal to negative 50 plus 510. So taking 50 away from that, this should be 460. So my y value is 460, my x value is 30. Now we can move on to number 5. Okay, so a segment has two endpoints, negative 810 and negative 94. What are AB? Now that's going to be a distance AB and the midpoint of this. I don't know which one I want to find first, but I'm kind of partial to finding midpoint. So if I'm finding midpoint looking at this, I know it's just averaging. The x value by midpoint and the y value by midpoint can be calculated separately in this enhanced equation as x1 plus x2 divided by 2, which is the average of the x's, and the y1 plus y2 divided by 2, which is the average of the y's. So if I call this kind of like my point 1 and this is my point 2, that allowed me to do some very quick substitution. X1 plus x2 should be negative 8 minus 9. And my y1 plus y2 should be negative 10 minus 4. Now if you're wondering how these change from pluses to minuses, well, just think about your properties of numbers. If I have a negative and a positive together, the negative is stronger, hence will take over. So finishing this up, this should be negative 17 over 2, and then negative 14 divided by 2, which is simply negative 7. I'll leave this as improper fraction. It's actually a better answer than a decimal, even an especially an approximated decimal. Okay, but there we have our midpoint. Now the second part is just finding my distance. This requires the use of a distance formula. We've had at least 2 different forms of distance formula. I'm going to use the one that I prefer, which is the AB distance can be found using a derivation of the Pythagorean theorem, which is delta x squared plus delta y squared. In other words, how far apart of the x is squared, how far apart of the y is square that too. This can be done mostly in our head, which is really why I like this form of the formula better. Instead of trying to fret over all these negatives and adding the squarings, I'll do it all pretty much in one step. And here's why it's easier. If I'm at negative 8 and I'm traveling to negative 9, that's a total distance of one value. I'm going to square that to find my distance, and that is a square, believe it or not. Check out our y's. Negative 10 to negative 4, that's a total distance of 6. So I'm not even going to worry about negatives. I just know it's distance, so it's always positive. So I'm looking at the square root of 1 plus 36, which is just going to be the square root of 37. And I don't need to simplify that. That's a perfectly acceptable answer. 37 is prime. It can't break down any further. A decimal approximation, and it is simply that, a decimal approximation. So this will be much better in terms of accuracy and precision. Question 6. So let's find the value of x. Hello. Give me that pointer tool. Or not. Okay, there it goes. Okay. Find the value of x that makes ML parallel to M. Well, this is all about kind of using the converse theorems. So the question is really asking is, can you find a set of angles in the exact right position so that L and M are going to be parallel? Now, there's extra lines in here thrown for distraction, but don't let them distract you. All we really need to do is pick 2 lines in a transversal and then pick the right set of angles that enables me to that enables me to actually conclude my lines are parallel. So I'm looking for corresponding, I'm looking for consecutive interior being supplementary, opposite exterior. I'm looking really for anything that will help. Now here's the ultimate problem. I don't know if I have those angles given to me directly. It looks like I'm going to have to work for it a little bit. Here's the reason why. If I'm looking at 5x plus 40, If I'm looking for an opposite exterior pair, I'm looking for this entire angle. I don't have it. I only have up to this line. If I'm looking for a corresponding set, I'm looking for this guy right here. I don't have it. I couldn't even flip vertical because 5x is just going to be this part. 2x is actually going to be up here. I think my only hope of this is really going to be looking for consecutive interior angles being supplementary. And again, allow me to explain what I mean. If I can look at 2x and I can look at this angle right here, I know they have to sum together to make 180 degrees because they're supplementary. I know I'm not giving this directly, but hopefully you guys are recognizing that I have it vertical, which really makes this 5x plus 40. Now I'm in business. If I add these two angles together, I should equal 180 because they're supplementary. So I have 2x plus 5x plus 40 is equal to 180 degrees. Now just turn into a solving problem. So we have 7x is equal to 180 minus 40, so that's going to be 140. Divide both sides by 7, and I should end up with 20. So the value of x that makes these two lines parallel are going to be 20, because they're going to be the values that actually make the two inner angles on the same side of the transversal consecutive interior angles supplementary. Alright, so again, I hope this helped. Hope you guys are doing this hopefully before Sunday night. If you're listening to this video on a Sunday night, don't even tell me that. That'll just be depressing. Because Sunday night is the last day of your quiz being due. So I hope this helped. If you have questions, again, please post them below the video link, and I'll try to address those as soon as I can. If you need me to kind of talk about a problem more in depth or anything, again, please post it below this link, the video link, on my Edmodo page. So I hope you guys are having a safe Halloween, or had a safe Halloween, depending on when you guys looked at this. And I will see you guys later. Goodbye.